Okay, so I want to introduce Arabic mathematics. We'll spend a couple of classes on them, maybe, and we'll kind of trace what happened after Diophantus to the founding of what's called the House of Wisdom. Okay, so Diophantus was a black swan. There was no one else like him, as far as we know. It's not like he spurned a new developments in mathematics. He did what he did, and it just does not seem to have been followed up on him. But he did sort of usher in the Silver Age of Greek mathematics, which lasted from about 250 to about 400. It was the last gasp of Greek mathematics. But before the Silver Age, we should talk about the end of the Golden Age. Depending on the storyteller, historians often cite the death of Apollonius or Archimedes as the end of the Golden Age. I'd like to end it with Archimedes, since he died defending Sicily against the Romans, and with the rise of the Romans came a denouement of Greek mathematics. Unlike Greek culture, the Romans did not place a high value on pure math. As Cicero, a famous Roman senator, writer, and orator, said, "The Greeks held the geometer in the highest honor. Accordingly, nothing made more brilliant progress among them than mathematicians. But we have established as the limit of this art its usefulness in measuring and counting." Romans did not support advanced mathematics. It didn't seem to be integral to their cultural fabric. I know almost no major mathematical developments that came from the Romans, but it should be said they were excellent engineers, so they were very good at applying what they knew. Upper-class Romans did not hire tutors or buy slaves to teach mathematics to their children the way the Greeks did. It came to pass that virtually no one in Rome could understand Euclid, much less Apollonius or Archimedes. Perhaps Alexandria was an exception. So remember, Alexandria it's on the coast of the Mediterranean, and it's part of present-day Egypt, but that was a height of Greek culture, even after the Romans conquered the Greeks, because one thing the Romans did not do, as long as you paid them homage and didn't try to mess them up, they let you be culturally, as long as you paid your taxes, your tribute, and behaved. So within that, the Greek culture survived in Alexandria, perhaps more so than in other places in the mainland of Greece. So Heron of Alexandria was a famous Greek mathematician, and he developed a formula for the area of a triangle, which is pretty ingenious, any kind of triangle, and also apparently was an expert surveyor and developed lots of techniques, mathematical techniques. Greek astronomy flourished. Ptolemy, who lived from about 100 to 178, developed a system of astronomy that placed Earth at the center of the universe. Now, this wasn't speculative. He mathematically could describe the motion of the planets and the stars very accurately with a very complex system, often in base 60. At least his observations were in base 60. He used a kind of trigonometry. Copernicus considered Ptolemy's The Almagest a great work, and this notion of the Ptolemaic universe with Earth at the center was overturned by Copernicus in about 1643 with his On the Revolution of Heavenly Spheres. But on the whole, there was a great quiet in Greek mathematics until Diophantus. Pappus, who came after him, I don't know much about the connections, if there were any, consciously tried to resurrect Greek mathematics, which his compendium of the Golden Age mathematics, the collection. If you read about that time, he had a lot of famous mathematical problems. There's Theon of Alexandria, and he compiled an edition of Euclid's Elements. His daughter Hypatia may have assisted him with Euclid's Elements, and she's probably the most famous female mathematician of the Greek world, although there are others. There's a letter from Archimedes which looked to be to a female mathematician. But anyway, Hypatia is like shrouded in myth. We don't know much about her. I think there are 4 sources of her which are considered original, but I think the first one was written long after her death, maybe a century or 2. She was caught up in a political struggle for the control of Alexandria between the powers that be, largely pagan, and an insurgent Christian population. We'll see more about this in a minute. In any event, she died tragically at the hands of a Christian mob. Uh, as I mentioned, she's the first woman to note of mathematics, and so a lot of people will sometimes ascribe to her things which we just don't know if they're true or not. I mean, modern people. Like I say, there's very little that we know about her. By the end of the 300s, I want to kind of get a little bit of the cultural background for what I just talked about. At the end of the 300s, the Roman Empire had split into two parts. There was the eastern part, the Byzantine Empire. That was Greece, Turkey, and Egypt for a while, and it lasted for quite some time, and at least another 1,000 years in some fashion, until 1453 when Constantinople was conquered by the Turks. The Western Empire fell in the late 400s when Rome was sacked by the Goths, though apparently it wasn't quite so much of a sudden thing, but a real gradual decline. It sounds like Rome wasn't really able to protect itself. The Eastern Empire had converted to Christianity and tried to convert its citizens, and this was probably part of the dynamics that led to Hypatia's death. This also led to the eventual closing of Plato's Academy, although it's not clear how much it still had in common with the original Academy 900 years before. As part of the conversion efforts, Greek temples were closed. Also, libraries with manuscripts were destroyed. Many parchments were scraped clean and reused, and you know about this. The Greeks had transitioned by that time. We're talking 800 years later, after Archimedes and Euclid, to use parchments, which were crafted from animal skins. Again, you've learned a little bit about this, I hope. I've already mentioned Plato's Academy, but the destruction was not complete, and we will see that the Islamic world would open up its arms to the mathematics and preserved a lot of Greek mathematics. Okay, so I want to talk about the ascendancy of Islam because that's the story behind the story of the rise of Arabic mathematics. In the early 600s, the Prophet Mohammad fled Mecca in fear for his life and understood a journey to Medina, which has come to be called the Hijra. Within 10 years, Mohammed established an Islamic state, which afforded protection to Jews and Christians alike. In 630, he returned to Mecca in triumph. However, in 632, Muhammad died suddenly as he was planning an invasion of the Byzantine Empire. And after his death, his followers conquered many Arabic lands, including Mesopotamia and Egypt, and with it Alexandria. And they may have destroyed his libraries, although they may have gotten a bad rap historically. A lot of historians talk about the Islamic sacking of the Great Library of Alexandria, but this may be more Islamophobia. And some people, I read something to the effect that a lot of these libraries had already been destroyed by the Roman Empire in part of their efforts to stamp out, the remnants of Greek paganism. And again, as often happens after a great leader dies, there was internecine strife among his followers, and there was a warfare for the next 100 years on and off. And there was a split in the Islamic world, as with the Romans before them, between the East and the West, and we are concerned with the East. Now, in the East, after a century of conflict and little intellectual activity, culture arose quite quickly in Baghdad. The Caliph al-Mansur founded Baghdad in 766, and Baghdad quickly became an Islamic Alexandria. The Islamic miracle, it was sometimes called, and it's akin to the miracle of the rise of Greek culture, 1,000 years before. In the late 700s, a visiting Indian scholar brought to Baghdad an Indian astronomical text, which contained Indian trigonometric numeric systems. This is the source of the Hindu Arabic number system, the one that we use today, and particularly the zero. The Caliph Harun al-Rashid, who ruled from 786 to 809, founded a great library in Baghdad, and he collected manuscripts from all over the ancient world, including mathematics from Greece. The next Caliph al-Mamun founded what has come to be called the House of Wisdom, and he invited scholars from around the world to the House of Wisdom, and it was a great, it would be like a great center of learning and culture, like some of the great colleges in the present-day world. Ancient day mathematics, Euclid, Archimedes, Apollonius, and others were translated into Arabic and, more importantly, studied. Um, there's a famous mathematician, Muhammad al-Musa al-Khwarizmi, and he wrote the condensed book on the calculation of restoring and comparing. Well, why does that matter? It's also called, it can be translated, semi-translated, as the condensed book on the calculation of al-Jabr and al-Muqabala. They'll say al-Jabr a few times. See what word you come out. Al-Jabr, algebra, algebra. And it was an algebraic elements. It collected what was known about algebra. Now, the algebra was the restoring, and then you made all the terms positive. Now, there was some manipulation of things. The notation wasn't at that point like ours, and you'll hopefully have time to go over an example. Not today, but in class. And the al-Muqabala was the balancing. That's a gathering like terms, and I have an example there. And the solution there was x equal 1. Still at that point, there weren't negative solutions. There's also a negative solution to that quadratic. Al-Khwarizmi. Say that several times. Al-Khwarizmi, Al-Khwarizmi, algorithm. Yeah, that's where our word algorithm comes from. So a lot of the words we use come out of Greek mathematics. Again, like algebra, algorithm. The zero was called El Sephirim, which cipher. Zero, cipher, nothingness. So again, a lot of words that we use in math come from the Arabs. Now here are some other highlights. Tabat, he translated Euclid, and this probably influenced him to ground his approach to solving quadratics to Euclid, which you can do. We didn't do this. For example, you can solve quadratics, this particular quadratic, using Euclid 2:6, and there are some that thought that Euclid got that from the Babylonians. There are others who are violently opposed to that idea, as I found out. There's Al-Samawal, who was born Jewish but converted to Islam at the age of 40. He talked about the addition of rules for exponents, both addition of exponents, negative exponents, and also rules for manipulating negative numbers. He also worked on the division of polynomials. Again, I doubt we'll have time for everything, but we might look at his things. There's the famous poet Al-Qiyami, known to us as Omar Khayyam, and he's the author of the Rubaiyat, which is an epic poem, and it's a Persian epic poem. And he expanded the theory of equations to the third degree, which he solved via conic sections. Now I say solved, but he reduced the solution to doing these things with conic sections, which are very hard to do. So it really is not a useful solution. It's not our present day third degree equation is not based on that. So there are some other noteworthy developments in Arabic mathematics. There is the development of decimal fractions, the development of a fuller trigonometry, a more pure, less geometrical concept of number. So what was the influence of the Arabic mathematics on Europe? Well, some of it came in through Fibonacci, which we'll talk about, around 1200. But by and large, the Europeans remained unaware of many of the ideas in Islamic mathematics. In fact, Europe did not begin to develop an original mathematics until the Italian Renaissance in the mid-1500s. And a lot of what we know today about Arabic mathematics, I don't think was known to the Europeans, even in the 1500s and 1600s. But everything fades. As in Greece and in Rome, knowledge and interest in mathematics faded, in part due to religious and political dynamics. Once seen as a path to God, mathematics eventually began to be seen as too secular, foreign, and corrupting. By 1100, the House of Wisdom was no more, although there were still mathematical developments in the Arab world. So we'll talk about some of these developments in a future class, but at least now I hope you understand some of how we got to the Greeks and into Arabic mathematics. And later on, we'll talk about what Fibonacci did and what he brought into Europe. Anyway, thank you, and I will see you all on Thursday.